So also from 10.1, this is number 27, and this is the arc length, and you need to know this arc length formula by memory. It's very similar to the arc length formula in regular rectangular coordinates. And these are my limits, or the length of my t steps, or my beginning t and my ending t for my curve. So we're going to find the length of the curve from t sub 1 to t sub 2. So in number 27, so again, you look at your formula, and we went over this in class. X equals the cosine of t, y equals the sine of t, and my interval is t is going to be from 0 to 2 pi, so I want to find the length of the curve from 0 to 2 pi. So we just put these in our formula. First of all, I take my derivative. Dx dt is negative sine t, and dy dt is cosine of t, so we just put this into the formula. Dx dt squared, dy dt squared. All right, and that's just going to be sine squared plus cosine squared, which is just 1. So it becomes very easy to take the antiderivative of 1. That's just, with respect to t, is just t. And I evaluate it from 0 to 2 pi. That's just going to be 2 pi. That's going to be 0, so pretty easy. Number 29. Again, I hope you can read these. It's a little bit light, but... Okay, so x is going to be 8 cosine of t, 8t sine of t. So if I take the derivative of that to get it into my formula, dx dt will be negative 8 sine of t, and then I have to use the product rule. 8t cosine of t plus 8 sine of t, so if you apply the product rule here, we get this. But the negative 8 and positive 8 sine t's become 0, so we just have this 8t. And then we do the same thing with y. We take the derivative of y, and again we have basically 8 cosine t, then we have to use the product rule here. And similarly, these 8 cosine and negative 8 cosines become 0, so we have 8t sine of t. So there's my derivative. There's my dx dt, there's my dy dt, and then we just put these in our formula. And we want to go t between 0 and pi over 2. So those are my limits of integration. Now when I square these out, I get 64t squared, and a 64t squared, and a cosine of t, and a sine t. So I can factor out that 64t squared, and I would have cosine squared plus sine squared. But that's just 1. So we just have 64t squared. And the square root of 64t squared is just 8t. So we're just going to take the antiderivative of that. So that's going to be 8t squared over 2, which is 4t squared. And I just have to evaluate that from 0 to pi over 2. And the 0 just zeroes out, so it's just put pi over 2 in for t squared, so for t. So we have 4 times pi squared over 2 squared, which is 4. So it just becomes pi squared. So that worked out pretty nice. So those are both those worked out very nicely, very easy. Okay.